Hello guys, welcome back to my YouTube channel. My name is Dr Sammy. I'm popularly known as Dr Sammy. Today we'll be treating calculation of force and friction on inclined plane. So now this is a diagram representing an inclined plane. So therefore there are some things you have to take note and formulas you have to take note to be able to calculate force and friction on inclined plane. But before I verge into this calculation, there's something you have to take note: the meaning of friction. Friction is just the opposition to force. And we have two types of friction: kinetic and then static friction. Static friction is the friction at rest, that is the frictions that holds the body from moving, that is that works on the body at rest. And then kinetic friction is the friction that works on the body at motion. So that's just the theoretical part of what friction. So now there's a load acting on this inclined plane, and then the load is suspending a weight but downward. And then the weight, I'll use an imaginary line to represent the weight. So let's say the weight is being suspended downward. Are we together? So the load is what suspending the weight downward. So therefore this line is mg, representing the weight the load is suspending downward due to gravity. Now also there's also an upward force that is perpendicular to the what? To the plank. And this upward force is trying to balance the downward force. So the upward force, I will use a line to represent it. That is the upward force carrying the load up on the plank. So the upward force is this straight line. So arrow, I'll use arrow to represent the upward force. So I can complete this upward force. If I draw this line completely, it becomes this. Now from this, you know this arrow is your normal, because it's the line of the upward force. So I represent the upward force as arrow, and the upward force is called normal. So this arrow is called normal. So now this, we want to complete this triangle. Now there's something occurring on this load. If the load is being pushed, are we together? Let's say this load is being pushed by a force. Therefore, that is F, a force is acting on the load, so the load will start moving. But also, if this load is being pushed, another force will act on the load again, and the other force will be called friction. Are we together? So if this load is being pushed, as the load is moving, another force is acting on the load, which is friction. The friction is opposing the force. So please take note of this. So this third side will be my force. Are we together? Now there's also an analogy you have to take note of. If the body is at rest, the force is equal to the friction. That is why the body is not moving. But if the body is at motion, the force is more than the friction. That is why the body is moving on an inclined plane. Okay, now this side is the angle made by the inclined plane with the horizontal ground. Okay, now this side is also same thing with theta. This theta is also same thing here, theta. So the angle made here is also theta. Are we together? Now let's use SOHCAHTOA. Let's use SOHCAHTOA to calculate our force and normal that is acting on this load on the inclined plane. So how do we do this? If we take cos theta, so chi is adjacent over hypotenuse, So if we take cos theta, we'll have, now the side facing the angle is called the opposite. So here is opposite, and the longest side is called the hypotenuse. So here is hypotenuse, and the last side is called the adjacent. So you have adjacent over hypotenuse, so it will be arrow over mg. Cross multiplying, we'll have arrow equals to mg cos theta. So now for our normal on the inclined plane, this is the formula to calculate the normal. Now let's if we take sine theta, sine theta, since we know sine is what, opposite of opposite over what, hypotenuse, opposite over what, hypotenuse. So therefore, what is the opposite here? It is f. Sine theta equals to f over opposite over what, hypotenuse, f over mg. Cross multiplying, we will have f equals to what, mg sine theta. Are we together? So this is the formula for force on the plane, and this is formula for what, normal on the plane. Now remember, I said something that if the body is not moving, if the body is at rest, F equals to F arrow. If the body is at rest, please take note, the force is equal to the frictional force if the body is at rest. So are we together? So therefore, if the body is at rest, my F arrow could also be mg sine theta, because it's acting across the what? Across the inclined plane. Are we together? So that's just it. But if the body is moving on the inclined plane, are we together? The force that is causing it to move will be called, the force causing it to move will be what? F net. The force causing it to move will be what? F net. And then it will be summation of the what? Force across the inclined plane plus the frictional force. So F plus F R. Now that will be the what, formula for the F net if the body is what, moving on the what, inclined plane. Now before I forge further on what, simplifying this formula more, so that we'll see the end of this formula, there's something you have to know. Now the coefficient of friction, U, the formula for coefficient of friction is U equals to what? F over arrow. So U equals to F arrow, friction over what? Arrow. So if you divide friction with the normal, you get what we call coefficient of what? Friction, which is our U. So this is the what? Minimum friction every object has to overcome to start moving. That's what we call what? Coefficient of friction. So cross multiplying, we can have F arrow equals to U arrow. Are we together? So now further simplifying this formula, we have F net equals to F plus UR. Now F net equals to F is what? Mg sine theta plus UR U. So R is what? Mg sine theta, so it will be R is mg cos theta, so it will be umg cos theta. So please take note of this formula also. Are we together? So that's just the formula you have to take note. So you have to take note of this formula. F equals to mg sine theta. That's the force on the what? On the inclined plane. And then this is the normal to the what? To the inclined plane. And I told you that if the body is at rest, the force and the frictional force will be the same thing. So the frictional force can also be what? Mg sine theta. And I told you also that there is also a coefficient of friction acting on any body, and the formula is F friction over R. And then cross multiplying, we can have friction equals to what? Coefficient of friction U times what? Times R, which is UR. And then F net, that is if the body is moving, are we together? The force that is causing the body to move, I told that if the body is in motion, the friction and the force is not the same thing. So the force that is causing the body to move is the force acting on the inclined plane parallelly with the what? Friction. So therefore the force is F plus what? And you know friction is what? UR. So F plus what? UR. Now F on the inclined plane is mg sine theta. So anywhere you see F for mg sine theta, it is now mg sine theta plus U times R is mg cos theta, so it will be U mg cos theta. So please take note of this formula very well. And then U can also be U. Therefore U can also be mg sin theta. You know FR is mg sin theta over R is mg cos theta. Mg cos theta. Are we together? We can say mg cancel mg. Now sin theta over cos theta in mathematics, it is what? Tan theta. So U equals to what? Tan theta. So meaning if you are given an angle, are we together, like 30 degrees, and you are asked to calculate the coefficient of friction, which is U, therefore just take the tan of the angle, you get your answer. So please take note of these formulas. Very, very important. So I have 1, 2, 3, 4. Take note of this. Very, very important. Now guys, we have a case 1 question here. A plane at an angle 30 degrees to the horizontal has an efficiency of 60%. Calculate the force parallel to the plane required to just push a load of 120 Newton uniformly up the plane. So now we are asked to calculate the F net, because the force we are asked to calculate is to what? Push the load what? Of 120 Newton uniformly up the plane. So we are asked to calculate the force that will push the load what? That will push the load uniformly up the plane. So therefore, since the load is on motion, or since the load is in motion, and the force we want to calculate on this inclined plane is the force that will keep the load in motion, which is our F net. Remember, I told you that whenever you are asked to calculate the force that keeps the load moving on an inclined plane, the formula is what? The formula is mg sin theta plus umg cos theta. Now using this we get our answer. So therefore my F net will become mg, which is mass and gravity, is what? The weight you have been given here, which is what? 120 Newton. So 120 sin 30 plus u, coefficient of friction. Now we are given angle here, which is what? Theta is 30 degrees. So we need to calculate our u, and I told you that u is what? Tan 30. So u equals to what? What's the value of tan 30? The value of tan 30, to get our u, the value of tan 30 is what? Approximately 0.6. Are we together? So therefore 120 sin 30 plus u is now 0.6 times, now the force, which is the mg, is what? 120 cos 30. So my F net becomes, now 120 sin 30 is what? 120 sin 30 is 60, because sin 30 is 0.5, half. So half of 120 is what? 60, plus 0.6 times 120 is 72 cos 30. So my F net will be 60 plus 72 cos 30 is now what? 72 cos 30 is 62.35. So my F net will become, so adding the two together, my F net is 122.35 Newton. So this is the force that is required to what? To keep pushing what? The load upward on the inclined plane. Okay, now we have another case 2 of what? Of inclined plane calculation, which is question 2. Now a body of mass 6 kg rests on an inclined plane. So this body is not moving now, it's resting. The normal is R and the limiting frictional force is F, as shown in the above diagram. If F is 30 Newton, so the limiting frictional force, that is, this F is the frictional force, and the frictional force is 30 Newton, and this is 10 meters per second square. Then calculate the angle of what? Inclination. Now recall, I told you that when the body is not moving, your F equals to what? Sorry, your F arrow is same thing with your what? Your force. So therefore my force on the inclined place is mg sine theta. So therefore my FR will just be mg sine theta. Now, knowing this, my FR given in the question is 30. So my FR is 30. The mass given in the question is 6. Now times the gravity is what? 10 sine theta, and we're asked to look for the angle theta. So 30 equals to 6 times 10 is what? 60 sine theta. Now dividing both sides by 60, we'll have 30 divided by 60 will be what? 0.5 equals to what? Sine theta. Therefore, my theta, to get my theta, I have to take the sine inverse of 0.5. So theta equals to sine inverse of 0.5. Now, taking the sine inverse of 0.5, my answer is what? 30 degree. So the angle of inclination, which is theta, is what? 30 degree in this question. Now, so guys, go on and try this case theory question, and then after solving this case theory question, tell me how you feel. Drop your comments in the comment section below, and then before leaving this channel, ensure you subscribe for more wonderful videos. Ensure you do what? You subscribe, you like, and you share for more wonderful videos. Thank you for watching.